Hello, Chevet.
Hey, I think we are live now. Let
We
me
are
also just
live.
probably start that 30-second timer. I think like going without that is probably against the tradition. If that's fine,
Let's
Ben,
do it.
we can
Let's
start
start the
the
timer.
countdown timer.
Drum roll for the
Yes.
time.
All right. So we are live.
We are now
Oh,
officially live. Hello,
yeah.
Chevet. Good afternoon.
Yeah, good afternoon to you as well, Ben. And again, super excited to be back on a stream with you. I know we have been swapping with you and Laurent, and this is our fourth in the line of our build and deploy an AI app with the help of a lot of really great AI tools, and of course, building with Couchbase. So, super excited to have you back on board.
I am super excited to follow you on this journey and be part of the fourth and ultimate step in this
Yeah,
series of building this AI app. This AI app using AI tools. We're using the tools to build the thing that uses the tools. It almost
exactly.
feels a little bit recursive, but fun.
Recursive, yes. It's like the I keep on forgetting, like the Matrix, where you're
Exactly.
using the tool to build the tool. And I think like that's what I
Right.
really love about companies, that when you use your own tool like GitHub, I think they use GitHub to build with GitHub, right? So like
Can you
that kind of
imagine if they use Subversion to build with GitHub? How fun would that be?
I mean, I haven't looked into Subversion. Like, do you mind sharing what exactly is that? Is that another one
Oh,
of like
Subversion
uh,
is a version control system from
okay,
see this is what happens when you're an old man like me. You're young, you still got many years ahead of you. Subversion was
yeah.
before Git. It was revolutionary when it came out, but it had some
Hmm.
problems, namely around if multiple people were editing the same file at the same time and wanted to
Yeah.
merge their commits around the same time, that became a significant headache. Uh,
Hmm.
when Git came, it brought a lot of advancements. But Subversion back in the day, I still work on a project or two, by the way, Chevet, that is legacy tool stack
Yeah.
and uses Subversion even to this day.
Wow.
But yes, Subversion it's a way of saying it's old school. So can you imagine if
Okay.
GitHub, which is uses built on Git, was using Subversion instead of Git? Would be kind of funny. It's
Yeah.
as if Couchbase was using Postgres instead of a JSON document database.
Although, I mean, that does remind, like, Couchbase does have essentially like a SQL like layer. Of course, you still
It
store your
does, right? So
documents.
tell us about that.
Yeah.
That's actually very
Yeah.
interesting.
Yeah, so I mean, like one of the biggest differentiating factors as compared to some of the other NoSQL databases is that, like when you move away from SQL, there's still a huge learning curve when it comes to being able to implement certain parts of your queries. So of course, like if you talk about MongoDB and other such kind of NoSQL databases, there's a huge learning curve when it comes to learning how to query your data, right? So of course, with Couchbase, while it's still a document DB where you're storing your data as document and as JSON files, but we have what we call as SQL++, which was I think a successor to the N1QL. But with SQL++, the idea is that we have certain capabilities of SQL built into the Couchbase ecosystem itself, which allows us to write SQL-like queries, but still, of course, it is internally querying your documents like any NoSQL database. So you can write joins, you can do common table expressions. So like that's one of the unique things about Couchbase in terms of improving the developer experience, so that if someone is migrating away from MySQL, Postgres, and they are very familiar with SQL-like syntax, they can still use SQL++. and that allows them to use that similarity of using a SQL-like syntax, and also reduces the amount of query that you have to actually write, because for the same query that can be written in like one line, it might take you much more time to write a similar query in MongoDB. So I think like that's what I really love about the developer experience, and ensuring that
I think that
that
is
the developer
absolutely
experience.
spot on. I don't know
Mm.
about you. I'm sure you've experienced similar things where it's you're starting to build something new because either you want to or because your
Yep.
boss said you need to use this new thing or this different stack you've been using for. And the last thing you want to do is have to now learn an entire new company or vendor specific query language just
Yep.
to get your job done, just to get what you want to actually build. So
Exactly.
love it or hate it, anyone who's worked with data in a development environment is probably built with SQL, with SQL. So the fact that we have a query language that pretty much one for one parallel SQL, there's really only a couple differences, and they're additive. They're not. They don't actually change what you already know. They add features and functionality for working with JSON data, but they don't actually change any of the things that you already know and either love or hate, or love hate, whatever combination. It's really, really, really helpful. And I think you hit the nail on the head when you said it's positive
For sure.
developer experience.
Yep. Absolutely. But yeah, I think
By
like
the
with
way,
that in
everyone
mind,
who joined us, just briefly, please join the conversation. Chevet is an awesome guy. He wants to hear from you. I want to hear from you. If you have any comments or questions or ideas, please put them in the chat in whatever platform you're watching us from. And we would love to engage with you in the chat. So with that, just a heads up, don't be, you can lurk. We welcome lurkers, but we also welcome engaged participants as too. Whatever moves you, whatever you feel good for.
yeah, I think like just a heads up, like because we were having these live streams once every week on Tuesdays, so this is a new one for us because we wanted to actually get this project completed and then move on to some of the more exciting stuff with our mobile AI. So like I think there probably a lot of people might not be aware that we are streaming this, but we'll make sure to add the links of all of the previous three streams where we go really, really in depth with our Vercel V0 and Claude and Cursor, and of course the free tier with Couchbase, and how you can
All the
build
things.
AI
All the
applications.
things.
Yeah, we'll
Awesome.
make sure
So
to
I think
share
without
the
further
links of
ado, let's
all of
get
the.
going.
Yep, absolutely. So let me start by sharing my screen, and I'll also just kind of catch up to where we left on Tuesday. So less than 48 hours. So back to where we were. All right, perfect. So the last time what we covered was we essentially went ahead and we started to work on our integration for the chat app. So in the couple of streams that we have had in the last two streams, we have been able to successfully go ahead and do our data ingestion, which of course we did with Uben, and we were able to successfully store our data into Couchbase. That is with the help of the Couchbase vector store. And with that in mind, we started to work on the next part or the final part of our application, which is building our end-to-end Couchbase RAG application with the chat interface. So where we are now basically storing the user's messages and our messages from the assistant, and that is being handled with the help of the Vercel AI SDK, which is a dedicated SDK which allows you to store your messages, and it has again inbuilt integration with LangChain. So this is like specifically if you're building a Next.js or a React project that has support for Vercel AI. And then what we started to do was we created our post requests, which we'll continue to actually continue building on top of it, because of course of limited time we were not able to complete it. But we are right now focusing on our previous messages that are being sent to the chat. And then of course we have our chat prompt template, and this is really useful when you're building a chat bot, because of course given the non-deterministic nature of these AI models, they can give you a response, completely different response each and every time, even if you are sending the same prompt. So with the chat prompt template that's part of LangChain, what we are giving is we are grounding the expected response from the AI model. In this case, we are going to be using the LLM, the chat OpenAI. So we are going to be using OpenAI LLM in order to generate the response. But here we have given a dedicated chat history template, and of course the expected response, that what we expect the LLM to generate, including of course having the context which we'll provide to the large language model in order to ensure that we always generate the responses in the correct fashion. And we're also providing the context that we'll get from our retriever step. So in this retriever step, we are about to send a prompt, and then we will use the Couchbase retriever, which will find the relevant documents from our vector store and pass them with our given input prompt, so that we are able to retrieve the documents from that additional context that we provided, rather than the AI model hallucinating, so that we are able to chat with our PDF docs. So we went ahead and we have again followed the similar steps that we did in our ingestion step, where we are creating a new Couchbase cluster and we are adding our vector store arguments. And now what we have started to do is we finished off pretty much at the retriever step, where we have now used the Couchbase vector store retriever. And in this, we will pass our input prompt and we will fetch the list of documents which are the most closely related to our input to our input to our input prompt that we have given, right? So that's, I think, like a
Let's
good
pause
starting
there
point
just
for
for a
us.
moment, Shive. Let's pause there for a moment. That's been a great introduction. Let's talk for a minute. You said so many wonderful things, really wise things. One of the things you said at the very last minute was the documents that are closely related. How are we figuring out what's closely related? How does that actually, what's happening there? Can you give us,
Yes, absolutely.
standing on one foot, a 30-second recap of what that actually means?
Yes. So as part of the retrieval augmented generation, the key aspect over here to keep in mind is that as soon as you store your data in the form of embeddings, so when you give a new prompt, it also gets converted into an embedding. And then we use very industry standard algorithms such as KNN, which is the K nearest neighbor algorithm, that's primarily used inside of the vector search or the vector embeddings. So we compare what are the embeddings which are closest to the given embedding, and this given embedding is generated from the prompt or the input message that has been sent by the user. So first it get converted into the input embedding, and then we use the KNN algorithm to find the nearest embeddings. And this, of course, happens inside of the Couchbase vector search. And that's, of course, being interfaced right now with the help of the Couchbase vector store retriever step. So in this case, we are passing our input prompt, converting it to the embeddings, and then we are comparing it with the list of embeddings that are already stored inside of our database, inside of our collections. And then we find the nearest ones which are closest given our KNN algorithm, and we retrieve them and pass them with our additional context that we give to our vector database.
That was very helpful and very succinct, and I think that would be it was very useful for a lot of our viewers, both now and in future recordings of this. And let me ask you one quick follow-up question. That sounds like a lot of work. Does that take a long time, or is that a pretty quick process?
No, that is a pretty quick process. And of course, if you want to dive deeper into the nitty gritties of how these steps are actually taking place, I would highly recommend going to our blogs. And probably, Ben, if you can link to our blog, we have had a number of different articles written on our blog which cover how does actually vector search work under the hood. So of course we are giving a very high level explanation of how this KNN algorithm works, but then of course when it comes to doing this quick retrieval step of finding the most relevant documents, there is a lot of filtering that also actually goes on behind the scenes. And this is where we have centroids getting created and the entire search space being reduced to just the most relevant documents. So of course, like I'll not spend too much time going into that explanation, but yes, we have already covered that inside of our blog posts around vector search. So I'll highly recommend if anyone is interested in knowing how all of this works behind the scenes. But the end result is that we have actually done testing with millions of documents and having embedding size anywhere between 500 to the maximum that's supported within Couchbase, which is 2048 as the embedding size. And usually the search that takes place, even if you have millions of documents, can take place within a matter of a few milliseconds. So that's how performant the
Fantastic.
Couchbase vector search is.
That was super awesome. Okay, Shive, let's get
Yeah.
back into it.
Absolutely. So, of course, now considering that we are pretty much in the final steps of our RAG pipeline. So, of course, with LangChain, it's connection of a multitude of different chains. So far, the chain that we have defined is our history-aware prompt. So, this will be used inside of our chain that we'll create. And within LangChain, of course, we'll have like a history chain, we'll have a document chain. So, these different chains are mainly for accomplishing different tasks. So we'll have a history aware chain that we'll maintain, which will be primarily just for maintaining all of our previous history, like the chat history that we are going to be having. Then we'll have a document chain that's primarily just for actually creating a chain that's, answering questions related to the input documents, and which is basically sending the relevant documents as part of our entire retriever step. So we'll basically now go ahead and start defining those specific chains. So the first one that we'll go ahead and define, and for that I'll quickly go ahead and define our function over here. So the first one that we'll define is basically our history aware. So basically our create history aware. So basically this is what we are going to be using from our input. So this is pretty much like from our rack pipeline. So we are importing this from LangChain, where we are importing a specific chain for managing all of our history, right? So in this case, if we want to use this, we'll of course use this as part of our function. So we can create a new chain over here. So we can probably call it because we are using the create history aware retriever, so we can probably call it history aware retriever chain. So we can call it history aware retriever uh, chain. So let's do that. So we can do create history, and then we'll of course use this, and we'll just do an await because we want for this to complete. And by the way, what you're probably seeing is one difference, Ben, which you're probably seeing is that I actually ran out of the free autocomplete from Cursor. So of course, this is something to keep in mind, that you get limited, after which you'll have to probably then go ahead and start using the paid subscription. But that's something like, of course, you shouldn't always be reliant
The
on
real
using the
question,
autocomplete.
Cheve, is running out of the free autocomplete, is that a pride? Is that a point of pride or a point of shame? That I've used
I
it
mean,
so much I ran out of it, or I used it so much I was so smart? Which way do we want to look at that? I prefer the I'm so smart perspective as opposed to the other one, but
probably.
it's an
Yeah.
interesting question.
Yeah, and most likely because I've been just using this as part of the live streams only, and of course, like, it has been really helpful in completing certain parts. But what we saw was that it is not always going to be completely accurate. So that's one thing to keep in mind, and we are constantly reminding folks when they are using AI tools that they are not going to always give you the correct response. They are still growing as we are speaking, and they are becoming much better, so with time. So that's something to keep in mind.
Awesome.
Yeah. So now, of course, the three things that this particular function requires, and this is something that we can also always go back into the LangChain docs, is that we primarily require, of course, since we are maintaining an entire history of the previous set of conversations that we have had. So it basically requires three different parameters. So one is the LLM. In this case, we are basically passing our model, then the retriever, which is going to output the list of the documents that we retrieve from our vector store, and the prompt. So basically the prompt which will be used to actually generate the search query, right? So in this case, we are going to be passing our model, and then we are going to be using our history aware prompt, which we have just defined previously. So this is going to ground the LLM response based on the template that we have provided, right? The answer template, and also the chat history template that we have provided. So this will allow for it to always send responses in this given in this given fashion. So now the next thing that we are going to be doing is we are going to be creating a documents chain. So this particular chain is going to be useful when it comes to basically answering your questions using the retrieve context. So using the documents that we have retrieved from our retriever step and passing them to our context so that we are able to generate better responses. So we'll just create a new documents chain. And in this case, what we're going to be using is that we have imported something that's specific, which is combining this document. So we're going to be using the create stuff document chain. This is used to again pass our LLM and like our input prompt. So as we are going to be, as you might see that we have added this context section within our answer template prompt. So this is where our retrieve documents will be passed alongside, right? So this is where we can now define our create a template. So this is our create stuff document chain. So this will be used when passing our additional context from the retrieve documents that we are passing to our RAG pipeline. So again, in this
Awesome.
case, the parameters that we require are basically our LLM. So in which case that would be a model. And the second thing would be our prompt. So in this case, the prompt again is going to be our answer prompt. So because we are specifically passing just the answer prompt, right? Because this, as you might see again, is this section, which is our inside of our answer template. So we are passing this additional context with our answer prompt. So that is why in this case, we are keeping this particular documents chain and we are passing our answer prompt inside of the prompt that we need. So now we have set up two different types of chain. One is the create history aware retriever chain, which will maintain the entire history of all of the conversations that we have. And then we have the documents chain, which is relevant for maintaining all of the additional documents that we get from our retriever step. Now, the final, I think like the two last chains that we require are basically the output chain. So this is essentially, the answer that we will get from the LLM, and we will output it inside of our chat. And then another chain that we would basically require is that basically combines the retriever and the question answering step, right? Again, because the word LangChain, right? It is essentially chaining together different pieces, right? So even in the retrieval augmented generation, there are multiple steps that are involved. So with LangChain, we are essentially creating these different chains so that we can structure the response from one, the output from one chain to the input of for the next chain,
And
right? So
what
that's
kind of
the
format does the response come back to us in? Do we need to do any post processing of the response?
so yeah, I mean, basically the LLM is just generating the response in text, right? So that's like when we stream the response, I think like it's either like a JSON
Is
object.
it in JSON? Is it in CSV? Is it in plain text?
No,
Is it in
definitely not in
Markdown?
CSV. So it is going to be in JSON, and then we can
Okay,
parse that JSON. Yeah, yeah.
right.
So I mean,
Maybe it's in
because
YAML. We never know. It could be a YAML response. It's
yeah,
good to check.
yes, yes, yes. But yeah, I mean, if you want to again then parse it, then you can probably create a separate chain altogether just for parsing it in a different format. So that's like one of the key things to keep in mind, that whenever you are using LangChain, so and if you remember from last time, we had this particular specific integration that we had from LangChain, which was a PDF loader. So in this case, we have certain types of document loaders, because LangChain supports loading your documents in PDF, in CSV file, in even something like a YAML. So of course, we have dedicated community loaders which allow you to load your documents in certain format. So similarly, like if you want to generate an output in a certain format, I've not explored that myself, but I assume that there might be a capability within LangChain which allows you to format your response in a desired structure, which might be relevant for the kind of application that you're building. In our case, since it's a simple chat app, the response that it generates as a text, we can just retrieve the text from that JSON object and just show it inside of our UI. So I hope that kind of makes sense.
That does. And if anyone has any
Yeah.
questions on everything you said, which Shavea said quite a lot and has covered a lot of wise wisdom,
Yeah.
please don't hesitate to ask in any of the chat channels wherever you are joining us from.
Absolutely. So now we'll basically go ahead and proceed before the final step, which is going to be our output chain. What we are going to be doing is we are going to be defining our conversation retrieval chain, which is basically combining both our retrieval step and, of course, combining our prompt that we give with the additional context that we have set from our documents chain. So let's go ahead and define that. So we'll basically call it, let's say, conversations retrieval step. So we can say conversations retrieval chain. And again, in this case, what we're going to be using is that once you have set this, we are going to be using the create retrieval chain. So this is our final step in this case. So we'll use this create retrieval chain. And within this, again, we are supposed to basically pass two main things. One is the retriever itself and our combined set of docs. So we are going to be passing our retriever and the documents chain. It just generated a bunch of code for us. But yes, this is going to be our conversations retrieval chain. And finally, the last piece, in at least in terms of the chains, because we have been spending a lot of time. But this again, something that keep in mind, that the more complex your structure would be for your track pipeline, because sometimes you might have even a much more complex pipeline where you are also doing a bit of pre-processing for your data. Then of course you might have more number of chains as part of your entire application. So our final one would be the output chain. So in this case, the output chain basically expects our conversation retrieval chain that we'll use, and then our our output response, then, and also finally like parsing the output, right? Because as you mentioned, that we want the output to just get generated as plain text. So that is what we'll basically do in this particular step. So we'll go ahead and define our output chain over here. So let's go ahead and do that. And so in this case, what we'll do is that we'll of course and in this case, like what we're going to be doing is that we will expect to use our conversations retrieval chain, and then we'll also require for us to generate the answer in inside of the text plane. And for that, like, let's probably try to ask the LLM over here. Like we can probably ask it that, okay, I now I'll probably give it the context of our entire code base, and here we'll like try to use Claude to try to see that, okay, if it is able to help create the output chain for us, just as a way for us to test whether it is actually able to understand and generate the function. So we can ask it that, hey, help us generate the output chain for our RAG pipeline, and generate the output response as plain text. Because of course, like what we want for it to do is that we want to generate the outcome. So basically we do have essentially an input that we had last time, which was basically the HTTP response output parser. So this is essentially like what we have as part of our line chain, where we are able to generate output in a given format. So considering that if your LLM is generating some other type of response, so we can parse that particular output and generate just the response in like, let's say, text. So in this case, like we should be able to provide the response in just the, like, let's say, plain text, or if you want in YAML, or if you want in like, let's say, JSON. So we are able to parse that particular output and generate a response in a dedicated structure. So now basically, of course, what we see over here is that instead of like getting an input that we are having as part of, let's say, this create output chain, what it has given us as a suggestion is it has given us runnable sequence. So of course, like we are using this particular function because it's essentially sourcing our because it's relying on all of the previous steps that we are having. So in this case, like we are going to be using the retriever, and then we're having the conversation chain, right? So which is coming from these particular chains that we have created, which are sourcing our input file, input prompt, then generating the retriever step, and combining that with our with our answer prompt template, and then generating the response. So let's go ahead and actually apply this if you want to use it. Like it's a really good, easy way for us to use this particular output. And then it also says that we'll also update our response function. But I guess like one thing that it does not actually do is that it does not use the HTTP output parser. So that's one thing that it does not actually take that into account. Now I could communicate that it should also use the HTTP output parser, because I did recently give it that particular prompt. So that's why, again, one really important step when using prompt engineering 101 is that you should give it additional context. So probably I will reject the output because it's not 100% something that we want to use, because we want to, of course, use this HTTP response parser. That's one thing that we would ideally want to use. But we can use this suggestion that we want to use this runnable sequence instead of like creating an output chain, because I don't think so there is actually a create output chain inside of LangChain, if I'm not mistaken. I don't think so they have this kind of function. What they have is this runnable sequence, which is useful when you're trying to generate your final output for your entire chain. But yeah, anything that probably, if you have any questions so far, by the way, Ben?
I think you're doing a fantastic job. I'm excited to see what comes next.
Yeah. All right, perfect. Okay, perfect. So now, based on the output chain that we require, so in this case, what we'll do is we will first of all just pass our conversation retrieval chain, because this is going to be the most important step. And I think like we should just have the await as well. Oh no, actually, await is not required in this case, because it just uses the runnable sequence. Okay, perfect. So we'll have this, and then we will also import a couple of things. So we'll of course define our HTTP response output parser, because we want the output to be in plain text. Is this like the way that we do it? I think plain text, or should it be text plain? I don't remember. I think it should be text plain, right? Because usually that's the way that we define. So it should be text plain. So this basically keep that the output that gets generated will be in the in this particular format. But looks like there's no property. Okay, let's probably ask it to fix this particular issue for us, because I'm not entirely sure if
the issue is the naming convention for it.
I'm not 100% sure. Let's probably see, like, because it seems that because we didn't define the content type. Okay. So let's actually go ahead and apply this.
Of course, right. That makes sense.
Yeah, that makes sense. I didn't provide the content.
That seems like a common error as well. I often forget to define content types. I'm like, wait, why isn't it working?
Exactly.
And that's why.
Yeah. And then the final step that we'll also need is defining our runnable pick. So here, essentially, because what we want is that the output chain is going to generate a response for us. So what we're going to be defining is that we'll define a key for answers, because this is like the answer that we are going to be generating. So like this should be good enough. Okay. So we have defined our conversation retrieval chain. We have defined that this is the expected response formatting. So we want it to simply just go ahead and define the response in plain text. This should be good enough. We can close our output chain. So we have, again, just to we have created all of these different chains, which is for maintaining our history, for retrieving our retrieval documents from our system, and then finally chaining it out together and generating our response. So now, once we have gone ahead and this, we are now pretty much at the final steps, which is converting so basically just serializing our documents and creating a stream, because we want to generate a stream. What we want to do is that as soon as the LLM actually starts to generate the response, we can create a stream so that we can stream the response rather than waiting for the model to actually complete the response. So we'll just define a function, or we'll just define a variable called stream. And in this case, what we'll do is that we will wait for our output chain to generate the response for us. And we'll use the stream function in this case, like what we have is the input. So in this case, like the input that is being sent is the current message that we'll have, right? So the current message content, and then we'll maintain our chat history, which has all of the previously formatted messages that we have basically sent. And we can probably comment this out for now, but yeah, this will allow us to stream the responses into our chat application that we'll be showing you very shortly. Now, I think
Would
like the
just
final,
a quick question, Chevet. If we
yeah.
were building this for production purposes, would you be doing any kind of validations or checks on to interrupt the flow of the stream to ensure data integrity, or that what we're receiving is what we're receiving, or would you
Mhm.
just let it stream and assume the best?
So I guess like is your question more related to that? Let's say if there is some sort of disruption with the internet, and that causes probably the stream to pause or the stream to not work properly.
I think we lost Chevet for a minute. My question was really around,
Oh,
sometimes LLMs can produce
can you hear me, Ben?
responses
Oh,
that are
I
not
think
always. Sorry, Chevet, we lost you for a minute. I was saying, I think
seems to
sometimes
be a bit strange. Okay,
we can LLM sometimes we receive
can you
response
hear
from
me, Ben?
LLM that we don't. Yes, can you hear me?
Oh,
Hello,
something went wrong.
Chevet. Chevet, are you with us? Hello. Well, Chevet's going to come back in a minute, but what I was trying to say was that LLMs sometimes produce for us responses that are not always predictable. And I wonder what the best practice might be. And it was an open ended question of whether we should always trust the responses from the LLMs that we receive, or whether it makes sense to just make sure that we're getting back some responses that the user would expect to get, and filtering out responses that maybe are error messages or validation issues or other challenges that the LLM might present, and presenting a more positive, or trying to present the most optimal user experience possible in dealing with LLMs, which are not always predictable in their responses. They don't always conform neatly to what we expect. Even if 9 times out of 10 the response from the LLM is what we expect, there might be 1 time out of 10 where the response is going to be something very different. So it was more of an
Yep.
open-ended question. What should we do in that case? Should we have any kind of filtering, any kind of pre-processing of or validations or error handling when we are streaming directly from an LLM to the user? Should there be any sense of check? I think that's a very interesting question, which I don't know if there's a single straight definitive answer for that question, but nonetheless. Well, while we wait for Chevet, I'm curious if for the folks who are here with us in the chat, if you've had any interesting experiences building with LLMs and working with data and databases and connecting the data, processing the data, trying to build interactive user experiences as you do so. So if you have any questions or comments or your own experiences on that, we would love to hear it as Chevet gets up and running again. Chevet, are you with us?
Yeah, yeah. Can you hear me
Welcome
now?
back.
I was not
Yes,
100%
welcome
sure
back.
what just happened.
Don't worry
Yeah,
about
thanks
it.
so
Don't
much.
worry about
I
it.
think there is something wrong with my UI. Let's see. Let me start to share my screen again. Okay. Hopefully this should be fine. Okay. Can you hear me now, Ben?
I can hear you, but your video is frozen, but we can hear you.
Oh, is it better now? Okay, perfect.
Nope, but
So
as long as we can hear
should be
you,
fine
at
now.
least we get your voice.
Yeah. Yeah, so I think like I was basically like, since we were discussing about like when what are the considerations when it comes to like having a stream. So I think like we were having a discussion around that whether it's a response getting generated from OpenAI, or it is perhaps like somewhere like your database actually stops working. So I was that probably the question that you had asked previously.
Yes, essentially, given that
Yeah.
data from LLMs are not always 100% accurate, or
exactly.
100% not
Yeah,
accurate necessarily is the word, but 100% predictable.
yeah, for sure. So I think, yeah, in that case, we can probably add in validation in terms of that. In case we start to see that the response getting generated from the model is probably not accurate. Sometimes, even for better user experience, if you're building this kind of a chat interface, you could just probably have like a delete symbol or like a pause symbol when you're in the middle of generating response, because sometimes you might actually accidentally press the message button and it starts to generate the response, and you accidentally realize that that particular response was not what you expected, or the response was not what you expected.
Right. It does seem
Oh,
like we're losing Chevet. There's some technical difficulties on Chevet's side. Not a problem. This happens to the best of us.
yeah.
While Chevet gets it
Can you
sorted,
hear
I
me now?
do want to mention that we are about a week out from the beginning of October, which means we're about a week out from the beginning of what everyone who loves open source knows happens in October, which is Hacktoberfest. So please
Yeah,
go check out the blog on Couchbase blog, where you will find blog posts discussing all the ways you can get involved with open source on Couchbase during Hacktoberfest, whether you're interested in IDE extensions, web frameworks, building out sample demo applications, building out in Rust a shell, Couchbase shell, whatever you're interested in, we have so much for you. So go to couchbase.com/blog and click on one of the first blog posts at the very top on Couchbase Hacktoberfest quest and get started soon. And if you haven't registered yet on hacktoberfest.com, now is time to register as a participant in this year's Hacktoberfest. So you get all the credit and recognition for your good contributions in this upcoming month of October.
yeah. Oh, but can you hear me now,
Yes.
Ben? Yeah, perfect.
Yes.
So I'm not entirely sure what's actually happening because my internet speed seems to be really decent. I mean, 100 Mbps, which is like pretty good for a stream. Uh, I'm not 100% sure.
You
Sometimes
know,
it can be a bit.
when there's going to be an internet problem, it's only going to happen when you're live streaming. That's just the rule. It has to.
And like the same with like live demos. That's
Right,
another.
exactly.
Yeah. Yeah, so pretty much like the final step that we have once we have created our stream is to actually return our streaming response. So what we'll do is that we will go ahead and just do like a return new, and pretty much I think we were getting this autocomplete functionality, but we'll go ahead and generate the streaming response, which of course is part of the Vercel AI, because this is where it natively supports the ability to stream response for you. And in this case, like we can pass certain headers, which can be passed as part of this. So in this case, like what we'll do is inside of our headers, we will first of all do two things. One is we'll have like, let's say, a header for the actual message index. So this allows us to be aware that what is the current message that we have actually sent. So in this case, we are going to be using this particular. So we had defined a function where we had formatted all of our messages. So this is where we are going to be using this particular variable for the previously formatted messages. So let's go ahead and keep this over here. So in this case, we are going to be having all of our prior messages. And then what we'll do is that whenever we want to add the next message in line, we'll just, of course, that is why we are adding +1 so that we have that message, and then we'll convert that to string. So this is useful when you want to, of course, generate your or stream your responses as a string. And then finally, we'll have the second header, which will be our sources. So again, like this is, and if you want to dive deeper into the actual documentation for the streaming response from Vercel AI, we'll make sure to go ahead and share this particular link with everyone, because this, as we mentioned, has a bunch of params including the headers, which we want as part of our response. So we're not like specifically adding the content type as text plain, because that's already being taken care of by our by the actual output chain that we have provided with LangChain. The only thing that we are providing are a couple of additional headers, but this is what we are going to be using for generating the actual uh, the streaming capability, right? Otherwise, if you wanted to implement this yourself, you'll basically wait for because like the way that the AI models, including OpenAI, they generate the responses chunk by chunk. So you have to manage all of that logic for yourself. But in this case, with the Vercel AI SDK, it actually provides you this capability on its own. So you don't have to manage that token generation, the output token generation yourself. It can all be handled with the help of this streaming text response function that we are basically writing right now. So the final one that we are going to be having is the X sources. So in this case, we're going to be passing one more thing, which is we want to basically serialize our entire document. So that's another thing to keep in mind. So before we do that, like we'll just have a placeholder for here, which we can say that we want to basically serialize our sources over here. So the input response that gets generated, we want to serialize that. So the final step over here would be to basically define our serialized response, the serialized output. So this is what we get from our documents. So once we have uploaded the documents, we want to serialize them. So, and basically this documents that we are going to be having are the relevant pages that we are passing as part of the PDF. So for example, if you wanted to like implement a functionality where when you generate the response, you also want to find what is that particular PDF file page from where we have found the context, because we are retrieving the context, but we also want to pass on some information such as that this particular file was, or this particular retrieve context was from page number 65 or from page number 70. So if you want to
For
pass all
sure.
of that information, uh, and if you want to pass that valuable information, because like of course if people are generating a response, we want to pass to them a relevant information of, you can refer to this source from the PDF. And let's say if your PDF has 1,000 pages, so you want to be able to share with them the relevant page information if they want to dive deeper into the actual text of the PDF. So that's like the reason why we are passing this over here. But yeah,
That
I
makes
mean,
sense.
by the way, like, you had any questions regarding that? But I think
No,
like
that
it's
makes perfect sense.
exactly, I think like it's super important for from a user from a UX, from a DX perspective, that we do that. Otherwise you give the correct response, but then if the user always wants to go back and they're not able to find that relevant resource, then of course like that's not a very good experience. So when you are generating that response, we also want to ensure that we are able to get the relevant data, right? So that's what we are going to be doing. So now we'll define this const serial sources, and for this, like again, pretty much similar to last time, when we were dealing with our files, and when we wanted to parse our files, we were using buffer. So if you recall, like what we were doing is, in this case, we were breaking down our entire file and using the bytes and the buffer in order to basically write that particular file inside of our directory. So usually that's the reason why we use. So in this case, again, we will use the buffer object over here, which of course we have imported. So which is part of natively part of Node.js. So we'll just use buffer. And now basically the idea is that we want to generate a JSON. So we will essentially use the JSON.stringify function, in which we are basically passing our entire page's content and the metadata that's related to that particular page. So again, the idea is that since we'll find the relevant text, we want to find out the page number that it's actually related to. So here we are passing all of the content of the pages and the metadata, which is like the page number, the actual document name, all of that metadata, and we'll basically use JSON.stringify so that we can convert it into that format. So like that's the step that we're going to be doing. So we'll use the buffer from, and this in this case, like what we'll do is we will pass. over here. So we'll use JSON.stringify. And now within this, like what we'll do is that we'll now pass our entire documents map. So because we are basically retrieving our set of documents, so we are going to be using this documents. So we'll use a dot map. So documents dot map. And now again, like what we are going to be doing is that for each and every document that we have inside of our documents, we'll basically return the pages content and any of the metadata that we have within this. So let's say that one by one we are having the doc. So in this case, now we'll use the arrow function, and we will basically, what we'll do is that we will go ahead and return the page content and the metadata that's related to that particular page. So what we'll do is we'll simply return over here, and we can probably have this as over here. Okay, perfect. So the first thing that we'll return is the actual page content. So we'll pass that page content over here. And so basically what we want to pass over here is the actual doc.page content, because we are retrieving that from our list of documents that we are getting. So in this case, what we'll do is we'll say page content is doc dot doc dot, oh it's giving me, okay, perfect. Oh, this autocomplete. Oh, what's happening? Sorry, this I'm not sure what's happening. Once again, I just want to use doc probably. Oh, this is really crazy. Okay, let me, oh, perfect. Oh, okay. By the way, I just want to ensure that the internet is working fine, because we have had problems.
We're doing a great job, and the internet seems to be smooth right now.
Okay, perfect. Yeah, so we just wanted the doc.page content, and then we can slice this because, like, considering that we just want like the first few pages, so we can just slice this as well, and this should be good to go. And then the next thing that we want is apart from our page content is our metadata, so which will be the metadata that we'll get from our doc. So this is, the autocomplete seems to be really sensitive. Let me just pass this, and instead I'll use the metadata. Perfect. So what we are basically wanting is we want our page content and we want our metadata that we basically want to pass. So this should be good enough. Let's see. I think like this probably something missing in terms of just formatting this correctly. Let's see. It says that cannot find the name doc, which is strange because we're using this inside of the documents.map, and then it's, oh, I think we are probably missing.
Maybe the arrow function is not defined correctly.
Correctly, yeah. So this is the end of our arrow function. Let's probably first close this. Now, are we missing? I think we're probably missing the formatting.
Missing a curly brace or something. Yeah, somewhere.
Yeah. So if we, yeah, that's probably no mistake. So
a common JavaScript problem.
Yeah. Let's see. So we are returning this over here. This should be fine. So okay. And we are closing out our arrow function over here. Let's see if we are missing. So declaration. Okay, we can probably remove this. Is this the correct format? Because let's see. So we use the map over here, and of course this JSON.stringify. So this should be fine. Oh, my bad. So I think what I forgot to do is close out with the curly bracket. So once we do this serialized resources, oh yeah, perfect. So I think this was the mistake. So I hope this should be fine now. Am I missing anything over here?
It looks like still the issue is there.
Let's see. So it's still expecting like a comma. So let me, okay. So we are using the from function JSON.stringify. We pass our documents map to return our page content and our metadata. Seems to be, let's see. I'm not exactly sure. So this particular closes out this. Then we have closed out our map function, and oh, I think this is one extra. Oh yeah. So this should be fine. So this closes our JSON.stringify. And finally, we have our buffer function. But it's still expecting like cannot find name doc. I think there's probably something that we are still missing. We can probably ask the AI to probably
Syntax
help us
error.
solve this. Let's see. Um, so like fix it. Let's see what it has to say. Probably some sort of formatting issue that we might be running into. So okay. I think there's this issue it's realized, and then parentheses around the doc. Let's try to apply this and see if it works. So we can copy this over, and hopefully this should. So I'll just comment out this for now. Okay, so it says that it is we removed the semicolon. Okay, so we didn't actually require this semicolon after the doc. So this is probably
It still seems to be some issue on the metadata.
metadata.
Does not exist on
Let me
type
check.
document recordings. Yeah.
Because normally, like the idea is that this metadata is actually this could be perfect. It is just a mistake with using camel case, so this should be fine now.
Okay, excellent. Okay.
Yeah, and now we should be able to use this serialized sources over here. So let me go ahead and pass this over to our streaming test response function. We're still getting this error, which is I think like we didn't complete this. So let's go ahead and okay. But we're still receiving this error inside of the headers. Let's see. Yeah, that's a rookie mistake again. So it should be headers. Oh, it still gives me an issue. So it's not assignable to the readable stream. Let's see. So this is not assignable. Are we missing something over
Because
here? So
you need to instantiate a new header from the constructor. Is that like is it new headers?
yeah, it's probably like a new header, but
Just
but
like
actually, if
just
we
like
look
you
at
did. Yeah.
yeah, because if we look at the implementation over here, it should be a small actually. So yeah, we were doing it correctly. It should be a small header. So it should be headers over here. I think like one thing that we can probably also finish up is that when we return this particular streaming response, we should also probably just have like um, a simple error statement just to ensure that we are able to handle the error. So
Right.
perhaps that could be like one thing that's we are probably missing. So let's just complete this over here, um, and just simply go ahead and do like a catch over here just to ensure that we are able to get that. So we'll just do a catch and just in like provide it a general error over here. So we can just say console.log and we can pass error received. Just doing a bit of the error. Okay, perfect. So this should be good enough. And we have defined the error at the end, and we'll just close out our program over here. One second. Okay. So this final piece that seems to be giving this issue with the headers. I mean, we have to use headers, so because it's going to be part of the streaming text response. Let me just see if we are
Oh, of
using
course.
the correct function. Let's see. Yeah, it seems to be fine. I would probably want to just take a look at an example implementation for the streaming response. Perhaps like we should be able to see. We could probably ask Claude, can you provide an example for a function from Vercel AI SDK? Instead of like looking for Google, like let's see if we're able to
Let's
generate
see
a
if you get
response
a
from
quick
Claude.
immediate response. Right.
Yeah. All right. So looks like what it expects is this returns the stream. It is not apparently passing custom headers, but since it's aware, we can probably ask it to fix this for us. So we could ask it that help fix this over here. So we can probably this passes and see if it's able to fix this for us. Let's see. Because I'm not entirely sure if this is like missing some headers, because normally, as you see, right, that it's actually passing headers param for it. So I'm
Right.
not entirely sure if something to do with the expected, like, I mean, if you're missing some syntax, like if there's some, seems to be some syntax issue, but doesn't seem to be, because we are passing the valid headers that it expects for us. Let's see. Probably you can remove this, so this seems to be additional extra. And then let's see. And we have to close out this with the curly bracket. Okay. Oh, I think like this seems to have fixed it, but the only issue is this headers. Let's see. Thank you for providing here's the corrected version. So it still gives us the headers, so that's fine. And I think we didn't close out this entire file. So let's actually go ahead and copy this over and see if this resolves it. No, we still get the headers issue. Just ensure that
Are
it's
we
correctly.
importing the right thing?
Yeah, we are. So it should be
Yeah.
this one. So import streaming test response from AI. So that's the Vercel AI SDK. And then also ensure
I
that
haven't
the
used this
serialized.
SDK before, so I can't be of too much help,
Yeah,
unfortunately.
yeah. I mean, this like I've just used it a couple of times before. It's just it helps you to be able to like stream, especially if you're using LangChain and OpenAI inside of your Next.js app. So it just provides you some ready-made templates and streaming capability, which you might have to like implement on your own usually. So that's like the one of the reasons. Like one thing I feel like probably we might have to do is that we might have to convert this into so we might have to use like toString to convert it into the base 64 format. So that might also be one of the reasons. Oh, perfect. So actually that resolved that issue for us. We just had to convert
Brilliant.
this serialized sources into a base 64 format. So I think in that case, if I continue to use my own code, oh, my bad. Just okay. So let's do one thing. I will revert back to my original code, and I'll use this dot to string then 64. Okay. So now but it didn't actually fix. So there must have been some issue with this code. But okay, let me go back and okay, now it's fine. But we are probably getting this one final error. Okay, so probably to close out the function. Yeah, perfect. So looks like we don't have an issue. So again, just for those folks who are returning, so we are creating a RAG chat component where the user sends a message. We are prompting it to the Couchbase vector to the vector store to fetch the retriever, so which will find the most nearest documents based on our current prompt, and then we generate our response. And all of this is happening by combining multiple chains. So we have our documents chain, we have our conversation retrieval chain, and then we have our output chain. So all of these are being used in order to basically finally like help us create our entire chain, right? And I think like this should not be I think like this was just one small mistake, so this should just be history. Yeah, I think that should be the case. Okay, so this looks good. Anything else probably that you might want to add to this? I think it looked good. We can remove this commented out code, but this seems fine to me. Probably I can start to run our app. Hopefully, because now we've defined our chain and they're now like they're generating output, and by this is connected to our API. So if I go search for API, I can go over here. So this is already defined because we are using the use chat function over here, and we are using the endpoint for the chat. And of course, like every time we generate a new chat, it will be having a new chat ID. So this will be used for our function. So let's go ahead and localhost. Hopefully, if everything is seeming to be fine, we should be able to correctly generate the response. But looks like, okay, perfect. All right. Okay, so we are into our app. Doesn't seem to be an issue. Let's go ahead and select our file over here. So in this case, I'll select this PDF file. And just for context, this PDF file is for like conference city.js. So by the way, like both me and Ben are giving talks over there. So this is like a talk
That
around
is
just the
true.
community partnership with city.js India. So looks fine so far. We have successfully gone ahead and also completed our installation. So this file has successfully been stored inside of Couchbase. So all of the embeddings and our chunks that we created from our PDF have successfully been stored. Now let's go ahead and try to see if we are able to get our um, app running. So we can probably ask it a question. Ben, would you want to decide like what question we should ask?
Ask it a general question. What are the main bullet points, the main ideas in this PDF?
Okay.
Give me
Yeah,
a
so we can ask it,
summarization.
give me a summary of the PDF file. Let's see if it generates. Okay, so we are waiting for response. Let's just keep a close tab on our. So we have called the API. We have called the chat API. So hopefully, right now, what it should be doing is taking all of our user prompt, passing it to our retrieval chain. So the history chain. Oh, it just completely it
Uh,
broke. Okay.
oh no.
Um, yeah. So let's see. It it threw some errors, which is like the okay. Let's see. So the user aborted a query. It just failed over here.
Shivay,
Let's take a look at
we're getting close to time.
the
I
time.
just want to
Yes.
keep us aware of that.
Yeah. Yeah.
You may need to push up this code into a GitHub repo and share the final results, maybe with a
Yep.
video
Yep. Yeah.
walkthrough
Absolutely.
at the conclusion,
Or
because
for
we're
now,
so
like
close. We're tantalizingly close.
yes, yes, yes. And for that, like what I can do is just for ensuring that we are able to at least get this, what I can do is I can perhaps take this particular part of the code, which is primarily showing us the page number, because this is what is actually demonstrating the page number part. So we could try to just quickly comment out this portion of this code just to ensure that, because if it's something related to the page number, let's quickly go ahead and perhaps ask like a question again, probably like, give me a summary of the PDF file. So I'll just ask it to generate the response again, because I think like the error was related to not
The
being able to
page number,
correctly
some
find
property
the
on the
page
page
number.
number or
Yeah,
something.
property
Yeah.
of the page number. So okay,
Uh, uh, uh.
about a PDF file. So at least it generated a response. Let's probably ask it a bit more specific question, perhaps, question related to what is the discount percentage? So what is the discount percentage for tickets to community members? So let's see if it is able to actually fetch this particular, because it was able to generate a response. So hopefully, if everything works well, we should see a response. Oh, perfect.
There we
There you
go.
go.
Shivay,
We got the response. So just so that,
bravo, bravo.
yeah, and
Well,
just
this
to
has
like
been
share that
quite
we
an
are not
incredible
making this up.
journey,
Yeah.
right? Are you going to post
Uh,
this on GitHub somewhere we can share?
Yes, yes, yes. I'll push this over to GitHub, and we'll ensure that this also goes into the YouTube links. And again, just to ensure that we are not making this up, you can see that in the PDF file we have the discount code. Now, I think like the reason why it might be probably not working for showing the actual page number. That's something that we can probably look into once we are once I
It's
think
going
like
to be
we'll be
some
able to fix
property
this
issue
offline.
related to it,
Yeah,
for
probably
sure.
some
Yeah, no,
property issue.
right.
Exactly. But yes,
Shivay, this
we
has
were
been
able to
brilliant.
successfully generate a response. Yes.
You've taken us on a
Yep.
4-step journey to building this
4 step journey.
PDF RAG
Exactly.
app using all the
Yep.
latest and greatest. Please, everyone, follow along. But if you didn't watch all 4 of these videos, live. They're all recorded, and you can watch them all at your own convenience at 0.75 speed, 1.25 speed, 1 speed, however you want to do it. You could do it on your own time, at your own pace. And keep on following us on
Absolutely.
our live stream schedule. In fact, if you go to our blog, you will find on our blog a schedule of our upcoming streams. So please go to the blog, and one of the first blog posts on the top of the page is that streaming schedule. And please keep up with us and join us on further adventures. Thank you,
Yeah.
Chave, for this adventure. This has been quite an adventure and
Quite
really a
an adventure.
delight.
For sure.
Thanks, everyone, for joining us.